Hello everyone, welcome to day 14 of competitive programming challenge. Actually today is Wednesday. That means we are having a contest. Everyone is in coach F. So I was thinking whether to participate in the contest or to just solve the questions. Uh, for today I'll be solving the questions from the module. After finishing the module we'll think of it. Okay, let's open our terminal and start the timer. And we have two problems to solve. I hope we'll be able to solve them today. And one is a list of list, and one is good pairs. Okay. First, let's solve list of lists. So autumn list.cp. Okay. First, we need to change into cp directory, and now let's open our file list. You are given a positive integer n and an array of size n. There are n list l1, l2, ln. Initially li is equals to ai. You can perform the following operations any number of times as long as there are at least two lists. Select two lists li and lj. Append lj to li and remove the list lj. Note that this means lj cannot be chosen in any future operation. Find the minimum number of operations required to obtain a set of lists that satisfy the following conditions. The first element and last element of each list are equal. The first element of all the lists is the same. Print minus. So the first element and the last element of each list are equal. The first element of all the list is the same. Print -1 if it is not possible to achieve this via any sequence of operations. So after performing all operations, we need to find the list should be the first element, the last element of each list are equal. The first element of all the lists is the same. Okay. Now the input format is first line of t, number of test cases, and contains an n. The second line of each test case contains n space separated integers. So it's an array, so we have a snippet to take it, and the constants are 2 and 10 to the power 5, 2 and 10 to the power 5. So we need to solve this in n time complexity or n log n. Now they are given for one test case, they are given 1. There is only one list 1 and it trivially satisfies the condition, so no operations are required. For two numbers 1, 2, there are only two ways to do an operation. Either takes list 1 and append it to list 2, or take list 2 and append it to list 1. In both cases, it is not possible to satisfy both given conditions at the same time. Here the answer is -1. For third test case, select the third list 2 and append it to the list 1. Then select the second list 1 and append it to the first list 1, 2. Finally, we are left with a single list 1 which satisfies the given conditions. It can be verified that it is impossible to do this using less than 2 operations. We'll take the third list and we'll append it to the first list, and we'll select the second list 1 and we'll append it to the first list 1, 2. So we'll get 1, 2, 1. This means lj cannot be chosen in any future operation. Find the minimum number of required to operate a set of lists that satisfies the following conditions. The first element and the last element of each list are equal. The first element of all the lists is the same. The first element of all the lists is the same. Okay, here the first element is 1, here the first element is 1, and here also first element is 1. Okay. So even when we are selecting the list, the first element should be same while we are selecting. I'm thinking for the approach to do this. Seems this question is a little hard. Okay, we'll come back to this question later. We'll solve this. Autumn good pairs, the CPP. It's actually good pairs. Okay, now you are given an array on B of length n each. Determine the number of good pairs. A pair I, j is said to be good if all of the following conditions are satisfied. I is less than j, and A of I is equals to B of j. A of j is equals to B of I. Okay. Input format of test cases. Then first line of contains integer and the length of the array. Second line contains n space separated integers in the array. Third line contains n space separated integers in the array B. Output format. For each test case, output the number of good pairs. Okay, here it is given 1, 2, 3. Okay, here there is only one good pair. 1, 3 and 3, 1. Here there is no good pair. Here 1. Okay, this and this one good pair. This and this one good pair. And I and j should be equal. Okay, I should be less than j. How do we have 3 here? Okay, here we are having 1, 2, 3, 4. But this is only 2. These are 1, 2, 1, 3, 2, 3. 1, 2. Okay. And okay, 1, 2 in this position and this position, these both are equal. And if you reverse it, these both are equal. Okay. And 1, 3. 1 and this equal. And 3 and 1 are equal. 3 and 1 is also equal. Yes. And 2, 3. 2 and 3 equal. And 3 and 2 is also equal. Okay. Okay, here 1, 2. Oh no, this is not equal. We have 1, 2, 3, 4, 4, 3. Yes. This is also a tricky question. We can start I and j will be always front of the I, and we'll compare, and we'll also compare the reverse. Okay. Now let's take our array snippet. Let's also create one more array, p of n, and let's redeem that array. Let's take a for loop. Can we solve this in? Okay, we cannot solve it in actually 10 power of 9. So if but n size is 10 power 5, so if we go for n square 10 power 10, we cannot solve it in n order of n. I mean, you cannot solve the given problem in order of big omega of n square, because 10 power 5 whole square is 10 power 10, which is greater than 10 power 8, which is the number of operations that you can run in 1 second. So we should be solving this in order of n log n or in order of log n. Here it doesn't affect our solution because these are the values of I of I and B of I. Our will get TLA only based on the number of the size of the array, which is n, because our for loop is based on n. I was thinking for an approach, but its time complexity is log n. I mean n square. So we'll take a map and we'll map the number and its position. Well, it doesn't help actually. Or else we can do in this way. We will iterate over this array and we'll save the position at which it is occurring, and even in this array we will iterate and we'll also save the arrays with position which is occurring. So let's say for this, the occurring storing array will be like 0 is not repeating, so it is 0. 1 is occurring and its position is 0. 2 is also occurring and its position is 1. It's like 0 here, 1 here, 2 here. But n will start from 2. I mean I will start so we'll remove the 0. So 1 is at 0 position, 2 is at 1 position, 3 is at second index, 4 is at third index. And for this array there is no 1, there is no 2, there is, okay, if they are not present then we'll have minus 1. 0, 1, 2, 3 is also not present, 4 is also not present, 5 is present at index 0, 6 is present at index 1, 2 is present at index 2, and I mean 6 is present at index 2 and 7 is present at index 3. So there is no number, so we'll just do nothing here. We'll print 0 for this 1, 2, 3, 3, 2, 1. 1 is at 0, 2 is at 1, 3 is at 2. Okay, now 1 is at 3. Okay, 1 is at 2 now. 2 is at 1 and 0. Now in this array we will go in reverse direction. If any number is found, then that number, then we'll add 1, and here it comes, and if it goes here, it comes here pointer. So we'll add 2 one more time. I mean the pointer initial will be here, and we'll say n minus 1 is here, and next we'll come here, we'll compare these two. If they are equal, we'll add 1. Then we'll compare these two. If they are equal, we'll add 1. But according to the question it says only 1 pair, right? Okay, even this question is also enough complicated. How do you solve it now? I hope everyone understood the question. They are given, we can solve it using n square. We'll take the first element and we go on comparing it with the okay, we need to find the good pairs. But I'm not getting any idea to solve this question. I'm just thinking for an approach, but I'm not able to get any approach actually. This question seems very complicated. I wonder what is the rating of this question. We can take the map and we can no, but I'm not able to think of a way for how to use the map. Okay, for now let's leave these two questions. We are not able to solve them. I couldn't even understand what we are. There is, for me it's completely blank. I'm not able to think of a way to solve these two questions. So for today, here are the two questions. Okay, we'll solve them later. So for today we'll be solving questions from practice and from layering. Since I am 2-star, we'll solve the questions of arrays from 1400 to 1500 2-star beginner level, and we have solved one of the question. Chef and walking on the rectangle, chef learning Hungarian algorithm. Okay, this one seems interesting. It is in our rating range, so you can see my profile here. It is 2-star and my rating is 1412, so this question is having a 1439 rating, so it's solvable by us. Okay, so we have done a lot of questions. I wonder, let's quickly check how many questions we have done. 28 questions within 14 days. Well, so it's quite good. Let's read the question now. Okay, let's create autumn hangelgo.cpp. Chef is studying computer science. Tomorrow he has an exam on algorithms and data structures. One of the algorithms he is required to study is the Hungarian algorithm. You do not have to know this algorithm to solve the problem. Okay. In the Hungarian algorithm, you start with a matrix of positive integers with n rows numbered 1 through n and n columns numbered 1 through n. The algorithm proceeds in steps. In the first step, for each row of the matrix, you should find the smallest element in this row, denoted it by a, and subtract a from each element of the matrix in this row. In the second step, for each column of the matrix, you should find the smallest element in this column and subtract a from each element of this column. The remaining steps of the algorithm are not relevant in this problem. Currently, Chef is practicing implementation of the first two steps of the algorithm. He wants you to check if he is doing these two steps correctly. You are given a matrix with n rows and n columns. Let's denote the elements of this matrix in the ith row and ith column by aij. Determine if the matrix can be result of applying the first two steps of the Hungarian algorithm on some matrix. Okay. Okay, let's read the input now. First case n lies, okay, it's an array, so let's take our array, and here the values are really small, so we can do this in n square. We cannot do it in n cube, we can do it in n square. So first, okay, and we need to output for each test case, print a single line contain the string s without quotes if the given matrix can be result of the first two steps or no. If it cannot. Okay, here the matrix is 0, 0, 4, 3, 0, 1, 0, 1, 0. Okay, 3. Okay, why does it say 3, 1, 5? Okay, let's take a matrix. This is the actual matrix we need to take, but he took another different matrix. The first step, the smallest inches in row 1 is 1, the smallest in row 2 is 2, and smallest in row 3 is 3. After subtracting, the matrix becomes, and the second step is performed in this matrix. In the second step, when column 1 is 2, column 2 is 0, column 3 is also 0. So we got this, and this is the matrix given on the input. So the answer is yes. It is impossible to find a matrix such that after applying the first two steps of the Hungarian algorithm, it becomes a matrix given on the input. So the answer is no. Okay, we need to find out whether such kind of matrix exists or not. Okay. We got no for this both, and yes for this, yes for this, and yes for even this. Okay, why are this both no? And why the rest of things are yes? Sorry, I thought the recording stopped for a second there. Anyways, so I'm thinking, how can we say yes or no? Is it based on the number of zeros in the array? 3, 4, there are 4 zeros. Here there are 5 zeros. Here there are 3 zeros. Like the point is, if you take an array, like here the explanation, you'll take some array and you need to reach to the given array, right? It can only be possible if each row has n zeros. How can you say that? Because you'll take the minimum number and you'll subtract it, right? And in columns, the order basis, in the first step of each of the matrix, you should find the smallest element in each row. So if you find the smallest element in this row and if you subtract it, then that smallest element will subtract the smallest element. So you'll get 0 here, and here also you'll get 1 0. Here also you'll get 1 0. Even in column wise also it will have 1 zeros. So row wise it should have zeros, and column wise also it should have 1 0 minimum, right? Why row wise? Because we'll take the row wise. In first step we'll do. In second step, for each column of the matrix you should find the smallest element and subtract a from. So even in column wise also we'll subtract. I guess that's it. Cancel. Sorry, I guess that's it. Even row wise and column wise when you subtract. So let's take int answer equal to 0. Let's take 2 loops, since we can solve this question in using 2 loops. It doesn't matter because the values are very less, so we can solve them in n square time complexity also. We'll take these arrays and we'll go through each of the element and we'll check if a of j and of I is equal to 0, then we'll increase the counter and we'll just break it. Okay, this is for columns, right? I will be fixed, j will be changing. I forgot in reading. We need to read a matrix. So it's a of n. And we are also having one more for loop. Int j equal to 0, j less than n, and j plus plus. And this line is inside it. Okay. That's it, we are reading. Okay, this is for columns. Or we can change. Okay, let it be for the columns itself. Now we need to do the same thing for the rows also, right? But it will be in this way. If we found a 0, then we need to find minimum 1 0. So that means in this case there is minimum 1 0 in this row, this row, this row. So 3 zeros. And column also 1 2 3, 3 zeros. So therefore those are we are counting 0 for twice, right? So we'll say if answer equal to 2 times of n, then we can find some element, some matrix in which we can perform operations and we can obtain the given matrix. That's it. Should it be greater than 2 into n? Even if it is greater, we can obtain, because in this array we got 1 0, we'll break it. We'll break the iteration and we'll increase the j value. Or it should be exactly equal to in this row. If we got this, we'll break it, right? So we'll come here. If we got, we'll break it. Got it, break it. So even in this wise. Okay, let's just have greater than or equal to. Now let's clear and let's compile our answer. What is counter? Okay, it's not counter, it's just the answer. And this is integer. We got warnings because of this. Seen, okay, of I of j. That's it, right? So let's clear and now let's compile and also let's that is a dot slash. Okay, it has been compiled. Let's copy all the, we got s, no, yes, yes. And if you will submit it, submission queued. Currently running test case 2. Yeah, it got submitted. That's it. And that's how we solve this. And let's go and solve one question from binary search. And let's apply the filter. Okay, we already have average flex question, but let's apply the filter of 1400 to 1500. Okay, average flex is the only question. Let's clear it. And autumn avg flex.cpp. Okay, now there are n students in a class where the ith student has a score of AI. The ith student will boost if and only if the number of students scoring less than or equal AI is greater or equal AI is greater than the number of students scoring greater than AI. Find the number of students who will boost. Okay, let's read it one more time. The ith student will boost if and only if the number of students scoring less than or equal AI, scoring less than or equal AI is greater than the number of students scoring greater than AI. Okay, I didn't get it. So let's just see our test cases. Before that, we'll take the array, output a single line, the number of students who will boost. So for 3 case we got 3, 2, 1, 3. Also we got 2. For 4 test cases we got 3. All 3 students got the highest score, so all 3 of them will boost. Only the student with score 1 will not be able to boost. Only the student with score 1 will not be able to boost. Okay, let's read this one more time. Only if the number of students scoring less than or equal AI is greater than the number of students scoring greater than AI. Okay, I think the question is here. less than or equal to AI, the ith student will post if and only if the number of students scoring less than or equal to AI is greater than the number of students scoring greater than AI. Okay. The people who are scoring less than AI should be greater than the people who are scoring greater than AI. For example, we are having 1, 2, 3, 4, 5, 6. So number of numbers less than 4 are 3, and the number of numbers greater than 4 are 5 and 6. So here these numbers are greater than the numbers that are greater than 4. I hope that's what he's saying there. Let's see for our test cases. So 100. People who scored less than 100 are 0, greater than 100 also 0. So we got 3. People who scored, this is 2. And people who score less than 2 are 1. People who score less than 3 are 1. So it is 1. People who score less than 1 are 0. Who score greater than 1 are more. So we'll not do anything there also. Basically we'll take the array, we'll sort the array, and the elements which are greater than n by 2, for them for sorting, if they're equal, then what we will be doing. Even that's a scenario where you need to think of. I thought like after sorting the numbers less than 2 will be 1, but greater than will be this many. So if the size is 6, right? So if it is 6, if you are selecting 2, of course 6 minus 2 is to its left it will be only one element, to its right there will be 4 elements. So greater than 2 will be 4, so it's not the case. It's not the case. And if we go for 3 less than 2 numbers, greater than 3 numbers, so n by 2 in the sense 6 by 2, 3, so we'll start from here. So of course from here we'll get boost. That's what I'm thinking. But what if the numbers are equal? Can we solve this question? We can solve this question in n square time complexity also, no problem. So we'll just take one for loop. Inside that for loop we'll take less a number called less and large or greater. You can take L and G also, no problem, but to understand, for better understand, taking in that way. And we'll start from J. And shall we start from J? Okay, we'll start from J. We should consider numbers that are less than 9, means we need to iterate before numbers than I. And here we'll say if Okay, now we'll check if the element is greater than the selected element. Yes, that is, if a of I is greater than a of j, then we'll increase the greater, else we'll increase the lesser. I mean less. Why not change even this to great and less and great? We'll change the less. After the for loop, after calculating greater numbers and lesser numbers, we'll say if greater than less, then we'll have our answer variable also. I mean the people who are boosting, right? So answer equal to 0. Now if you'll print answer, I mean you can print the answer. Okay, this is great. This question is binary search. Well, I got the answer 0, 1 and 0 instead of 3, 2 and 3. So okay, if it is also equal also, we'll just increase the greater. Okay, we need to compile, right? Okay, let's compile and let's run. Let's copy all this and let's paste. Now we got 3, 2 and 3. Okay, instead of equal to, a simple equal to, change our output, because if they are equal also they will be boosting, because we need to consider as greater itself to make it boost. So let's submit it directly. It got submitted actually. We got the correct answer. Let's clear. Okay. Let's close this. How many questions did we solve for today? Okay, actually we haven't solved average, flex and good. We solved average for good pairs and hang algo, we haven't solved them. And the list of lists also we haven't solved them, I guess. List of lists is yeah, we haven't solved it. Hang algo is the one we have solved it, right? It's the one we'll given a matrix and we'll be counting the number of zeros, and yeah. So let's just remove a dot file and average flex file. Okay, sorry, good pairs and list of list. Okay, we have solved 2 questions for today. That's quite good, and it is also because we are going for selective questions in our rate and range. Let's go for one question in strings. Let's apply 14 to 1500 and let's take 14 of 42 substring of a substring. That itself seems a little complicated, so let's solve that. So autumn sub string.cpp, and now okay, here in the path itself it shows the code of the question. You need not do expand and check for the substring code. Here itself it shows it. Anyways, let's read the question. Stephen gives you a string yes, and you have to find a non-empty string p such that p is a substring of s. No non-empty substring of p is a prefix of s. No non-empty substring of P is a suffix of S. Those are the two conditions. For all such possible strings, find the length of the longest string satisfying all the conditions. If no such string is possible, print -1. A string A is a substring of a string B if A can be obtained from B by deleting several possibly 0 characters from the beginning and several possibly 0 characters from the end. A prefix of a string A is a substring of A that occurs at the beginning of A. For example, code is a prefix of coachf and ODE is not. Okay, a suffix of a string A is a substring of A that occurs at the end of A. For example, chef is a suffix of, okay, but he is not. So he'll give a string, and we need to find the string that is both a prefix and a suffix, right? No non-empty substring of P is a prefix of S. No non-empty. If it is empty, yes, empty substring of P. Is he saying it should be a substring or it shouldn't be? Okay, let's take our string snippet and let's say it's only yes instead of S1. Now here is a test case. There is no string possibly which satisfies all the required conditions, thus the answer is -1. He's saying 2. This string CD satisfying all the conditions. It can be proven that no string of length greater than 2 exists which can satisfy all the conditions. Okay, if you take BCD, then B will be here, right, at the end of it. So how can we solve this? A, B, C, D, A, B. We are having a string S. So of course you cannot take the last element and the first element and the last element. It is quite a tricky question. We need to take an element, a substring which doesn't contain the first element and the last element, and the size is 10 power 6. So you cannot do it in n square or time complexity. Also you should have to do it only n order of n time complexity. You'll traverse. Okay, just take the last element and the first element and save them in let's take the last character and the first character and save them in 2 different variables and iterate over the loop. And if you find something, if you come across the same element, then you say 0. So I'm saying like you'll take int, okay, this character, right, char first equal to s of 0 and last equal to s of n minus 1. Okay, n is also not given, right? No, n is also not given. We need to find ourselves n. So int n equal to 0 for int I equal to 0 I less than, okay, s dot begin. Can we use s dot begin in strings? S dot begin on strings in C++. In this documentation we have, okay, we have iterator begin. For string iterator it is equals to, okay, it's taking string iterator, so string iterator I, and that's it, right? Should I have s3 also? Okay, doesn't matter. For this, for I equal to s dot begin and I not equal to s dot end, you need to increase the I value. If and let's take int count equal to 0, or say answer equal to 0, so they will not confuse between count and cout. So if I equal to first, or I equal to last, then we'll be saying ans equal to -1. Okay, else we'll be increasing the answer. Okay, let's just say 0 at the end of the day, I mean at the end of the for loop. If answer equal to 0, then we'll print -1, else we'll just print the answer. Now let's compile the substring and let's just run it, and we're having already, okay, we got an error, was not declared in the scope. So s dot, okay, what is the length of string in C++? Is the dot length or a dot? Okay, it is the dot length function. S dot length of -1. Now let's compile substring. It did compile. Let's copy all this and let's paste. We got -1 and -1 for both the questions. Okay, let's just change this iterator to int I equal to 0, I less than s dot length I plus plus, and we can say s of I, and even it is also s of I. If any one of any both the conditions is true, then we'll say answer equal to 0. Dot out, let's copy this both. We got -1 and -1. Why is that? Okay, at the end we are getting it will be equal to the last only, so we'll set a equal to 0 at the end for the last value. So we'll take the maximum value itself and we'll say comma max equal to 0, and here max equal to, if max is less than answer, then we'll say answer is the new max, and if not, max will be the max itself. And we'll count answer one more time. So in calculate the substring, if anywhere we encounter with any value that belongs to the end of the end or start character, then we'll stop there and we'll start counting again, so that we'll get the maximum, and we'll print max. It's not answer equal to 0. If max equal to 0, then we'll do that. Let's compile sub. Okay, it is substring, and let's clear. We still got, we got -1 and -1. So initially yeah, okay, for a of I, which is the first element, which is a, it will be first element, so it will be a is equals to, answer will be 0. For the second element also answer will be 0. For the third element, else answer will be increased. For D also answer will be increased. So this should be here. Is that the only problem? We got 2 and -1, yeah, but we need to get them in a new line. So for max, I forgot the new line. Okay, now let's compile our substring, and let's print the outputs. 2 and -1, we got them. Let's copy all this and paste here. Will it get submitted? We'll see. Submission is queued. We have solved pretty good amount of questions today. I mean 3. Every day we used to solve 2 or 1. Today we solved 3 questions. So currently, okay, this question is not solved. Okay, it did got solved. That's it. So I guess we can stop here. We'll remove this file, and all this code will be available in my Git repository, and I'll provide the link in the description also. Well, committing this, today's day 14, right? Okay, that's it. We need to think about what to do in the upcoming videos. Like, should I solve questions based on this, based on my rating level? And I also need to participate in the contest. Okay, tomorrow we'll solve today's contest questions. That is contest number 79, which is going right now. I didn't participate in it, so we'll solve contest 79 questions tomorrow. And that's it. Thank you.